Sculpting visualization is a project that was born out of a desire to increase scientists' ability to see more and understand more within their data through the use of artistic understanding of visual language. And specifically, the thought is that artists are trained to create rich, dense, visual elements that specifically are intuitive, direct attention, and tell a story. And so the thought was that if we could incorporate that expertise into actual data, large data scientific visualizations, that perhaps the combination would enable us to have not only richer visualizations to communicate data, but also more complex relationships and new numbers of variables set up within a visualization. The Sculpting Viz Collaborative is made up of a team from the University of Minnesota Interactive Visualization Lab who focuses on the technical ability to actually incorporate artistic language into scientific visualizations and data. And that team is led by Daniel Keefe. And then at the University of Texas at Austin, Francesca Sampsell, that's me, leads the visual team, and we focus on expanding the visual language, enabling organization of visual language, and interfacing with scientists specifically to see how we might apply this language to increase their ability to explore, understand what's in their data, as well as communicate it to colleagues in the public. The first few years of the project were spent, one, just building the guts of how are we going to actually import all these complex shapes and lines and textures and hues that the artists are making, and also how do we condense that enough to be able to apply it to data in virtual reality, because that was part of the project. It is much easier to see complex, multivariate, three-dimensional data in a virtual reality headset because of the spatial cues that are given to you there. And the artistic team was busily developing this expanded vocabulary. What are the kinds of shapes and forms, colors, lines that can actually be applied to data and be useful to the understanding of that data, and also give it an affective property. There's been last year at AGU, I presented the work just in poster form showing the phases of what we have created. But this presentation, I'm going to move on and talk a little bit more about what is in the system and how to use the system and where it might be useful to people, and also solicit some feedback from you. Here you can see a close-up of the same data. It's showing you the eddies, the movement, the flow within the ocean, and also three categories. Actually, these categories have to do with nitrates. Three categories of nitrates, and then you can see that the lavender are a separate category. So by having a richer range of shapes, you can make associations of groupings as well as properties. What you don't see here is there are some angular pieces that represent the metals within the water. Here you can see examples of lines. So you can see the range of line, we call them line quality in the art world, or line characteristics, color maps, and textures that can be found within the library. And then this slide shows what we call our applets. On the bottom are the tools that we use to import the things that come out of the artist's studio into the tool that will apply it to data. So on the lines, you can see I've got just a sketch pad there with a bunch of scribbles on it, and I picked one and dropped it into the tool on the bottom, and it makes a continuous line. In the middle, there's a tool for constructing color maps based on palettes and images and things. And on the right is an explanation of texture. So you can see how we've dragged and dropped this same image into the texture mapper, and we've chosen the selection of the area we want the texture. You can see we've taken the same collage and just dragged it into the texture mapper, which is the bottom right, and selected the region which has the texture we're interested in, and that shows up on the far bottom right and is then imported into the artifact-based rendering system so that it can be applied to data. One of the key features for the artists is the flexibility within the system, the ability to try out many different options, be it textures, combinations of hues, and just the combination of elements within the visualization themselves very quickly and rapidly to experiment with a number of combinations. So you can see there are four kind of fundamental aspects of the system that have enabled us to create these visualizations. And the first was some technical work that was done on sampling volume data in a way that represents the density of the data in alignment with the density of the glyphs, and allows quite a bit of flexibility in that kind of sampling, so you can experiment with that. And then the second piece is the artistic vocabulary that is really, it's handcrafted. And the reason for that is that we look at a lot of imagery that is, computer generated. And the computer generated vocabulary is much more limited. And it also disconnects us from our own attachment to imagery. I think if you look at a drawing done by hand versus a lot of the computer, not all the computer-aided imagery, there is a sense of connection to humanity. And then there's an amazing coding team at the University of Minnesota that enabled all of this to happen. And then the results are shown. You can look at them in your computer or in virtual reality, or actually there's several other methods. But the goal is to provide clear depiction of engaging scientific data. Being an artistic team, we were also looking for how does one engage and compel an interest in the science that's being depicted. And so you can begin to see now that by using the library and the expanded language that we've developed, the imagery that comes out of that exact same data, fuller, robust, and compelling imagery. So visualization tools of large complex data can be pretty gnarly programs. But we knew that if we were going to engage artists in creating visualizations, that we needed to break it down into a visual, intuitive interface. And so the team spent about a week together teasing out these concepts and systems. And so when you go to the interface, you'll find that we have the whole system has different components. There's, like what's your data and what kind of data it is on the left. And then the data variables, there are all different kinds of variables that are listed and the specifics from your data. And then on the right are the visual elements. So we have color maps, we have glyphs, we have lines, and we have surface textures. And examples of those four different categories you can see just inside of the right-hand side there. And then in the middle, we have what we call the towers. So for each variable, you click up a tower, or what kind of data is it? Say it's points. Okay, so that's leafy chlorophyll. And they're looking at the temperature of that variable, which you can see is inserted. And then they're also looking at which direction that is moving. And so you can see that the vector variables are there as well. And the glyph that's been chosen, it's kind of a leafy form, but that is an arrow. And then this yellow to blue color map enables the association with leaves, but also a fuller range of discriminability within that temperature range. Now I'm going to walk you through just a step of how the program actually works and how the whole thing comes together. And while this is not comprehensive, because it's a fairly complicated thing, we do give tutorials, and we actually sometimes even give them on request. So the first thing that you're going to do is you're going to open the library, and you can see I've got glyphs there, and I'm kind of populating on the right-hand side. I'm populating my glyph drop-down menu with whatever it is that I think I'm going to want. And then I'm going to go and I'm going to populate my color map library with the things that I think might be useful within the data that I'm working with. Then when I want to create the visualization, once I've gotten all the glyphs and color maps and things that I want, I pull in like what kind of data do I want. So I'm starting with a surface, and this surface is not an actual data set. It's what we call a synthetic data set. And but you can see within the program you can rotate it around and you can experiment and see what you've got. But on the tower, then you can say, okay, how do I want to color the surface? And what's the variable that I want to color the surface by? And so you can see I'm dropping on, there's the color variable, and I move over and I say, okay, I'm going to pick a color map, and there it is, and drop on the color map, and you can see how it changes right in the window. And if you want to adjust the color map, there are ways to do that. As often you want to align the color map with the data in a specific way. And then once I have the color map to the point that it fits my vision, I can add another. Here I'm going to add some glyphs, and you can see how the pieces lock like little puzzle pieces. And ooh, those glyphs are a bit too big, so no problem. First I'm going to put something on them so I can see what I've got. Then I'm going to go up and I'm going to adjust the size of the glyph. And oh, that's better. Now I can see the glyphs within the context that I'm looking for. I can make them a little bigger, a little smaller, move them around to make sure that they fit the whole kind of concept. And then I'm going to say, oops, but they need a different color map because they're not standing out. And the color map will need a variable. And you can see those, it shows up like here are the variables that are attached to this data. Oh, and there we go. So now we have a color map, and we have the data. And there again, we can manipulate the color map so that they have a little more contrast within them. There are also planes. I can put a slicing plane through it, and I can say, okay, what is the variable on that plane? And once I give it a variable, I can add a color map, and that's going to show me what's going on there. Well, it doesn't show me too much because the color's not very good, but we'll fix that later. And I can add textures to the surface from the texture library. And I can say, oh, what size do I want the texture? Or how dense do I want the texture? How bright do I want the texture? All kinds of options there. And so that now you can see that the texture is a little smaller. It stands out a little better. And lastly, I'm going to put on some streamlines. So you can see, again, the puzzle pieces match one another, and I get some spaghetti. And I have different line textures, and this is just the one that I have imported from the library, but you can import any number of them. Once you get the texture on, it's looking a little bit small. I kind of like the texture, I like the variety, but I think I might want to make it a little bigger. And I'm going to give it a color that contrasts with the other things that I've got. And if you're going to give it a color, especially if you're going to give it a color map, you need to give it a variable. That color map, oh, now it's not showing up too well. So this is why there are all these adjustments, is because the more elements that you have within an image, the more flexibility you need to balance out the weight of those elements. So I had to make the lines a bit longer so that you could see them clearly in this visualization, and look a little bit fatter. And there are also lighting controls that have a huge effect on what you can see and what you can't see. So that's just an example of the possibilities to show you a little bit about how it works. And I know that's a quick overview with a lot of holes, but our website is sculpting-viz.org, and there are a lot more tools and a lot more videos on how to and whatnot. So hope you've enjoyed it. Thank you very much. My name is Francesca Samsel. I'm part of the Sculpting Viz Collaborative, and we are a combination of the University of Minnesota and the Texas Advanced Computing Center at the University of Texas at Austin. Thank you.